Okay, so we are coming into then kind of the second part of this topic. And so what we really want to focus in on is the comparison between the primary curve and its reciprocal curve. And if we can nail down a lot of the properties in comparing it with a strong focus on our primary graph, then we almost don't even have to worry about remembering a reciprocal graph. We can build it as we go. So we're going to kind of take this first page in parts. What we're going to do is we're going to sketch sine x and cosecant x. Now, what I'd like you to do is sketch sine x and then use that sine curve to generate your cosecant graph. Fight the urge. Don't look back at the previous booklet. Take a look, use your sine curve, build your cosecant graph. We'll see if we match up. So pause the video now. Okay, we should be back. And so our sine curve, we know, starts in the middle and rises, hits its peak at pi by 2, 0 at pi, min at 3 pi by 2, 0 at 2 pi. Smooth curvature, curving down and curving up. Now we're going to use that curve to build the cosecant. So I have a 0 at 0, which means I have an asymptote on cosecant. I have a maximum at pi by 2, so I have a minimum. I have a 0 at pi, so therefore I have an asymptote. I have a minimum, therefore I have a max, and I have a 0. And I can draw this one a little bit better than the previous. And there's my last asymptote. And so, as we go through, now we should be able to put in the branches, having some decent curvature, and we're not really going to stress too much how exact this is. But as long as we have a decent curvature, there we go. Now, we've got our cosecant graph. What I'd like everybody to do, pause the video and build it going backwards. Now, I've given you a full grid, but what I'd like you to do is only graph going backwards to pi. Okay, pause the video, go. And we should be back. So our sine should be really fast. Our cosecant then should have a max and an asymptote. And so as we bring in that curvature, and that one, and there we go. Okay, now we've got our pictures, and what I want us to do is just to examine some properties of those graphs. So the first thing I want you to notice is when we fill in this table, we are only completing it for our first positive rotation, 0 to 2 pi. So I'm not using that region of my graph. It's going to be important for us to kind of see it a little bit, but I'm not using it. Okay, I want to explain the chart a little bit. And so, as I slide that up, we have some properties that we need to find. So, the first thing that I want to draw your attention to is that we are finding the x values at which those things occur. We are not stating y values whatsoever. We may be considering the y value, but we are always talking about the specific x value. What do we need to find? Well, we need to find a few things. And so as we scan our way down all those properties, I want to make sure that we're good with them all. Absolute means that it is the absolute, there is no other value that could be above that value. Now, what local considers is, does it act like a maximum in that vicinity, in that area? We'll talk about that as we go. We have the same thing with our minimums, we have our zeros, our asymptotes, and then we get down to the last two, intervals of increase and decrease. Let's walk through the sine curve to make sure that we can match up. So all I'm going to do is shrink down this picture a little bit so we can see everything in one go. What we're going to now do is examine my sine curve's properties. Okay, as I deal with the first one, when is the maximum of my sine curve? I know my maximum value is 1. When does it occur? Because I'm talking about the x value at that point. It occurs at pi by 2. If I go down, I state my minimum. I know my minimum occurs at 3 pi by 2. I know I have zeros at 0, pi, and 2 pi. There are no asymptotes, so there's none. And now I get into intervals of increase and decrease. And I'm going to ask you just to stop there for a second and we'll come back. What I'd like you to do now is to go through and fill in those same properties, but for your cosecant graph, for my blue graph. Okay, pause the video, go ahead, we'll see if we match up. Okay, and we're back. And so if I went to say my local max, well, if I examine on my curve, this would be the location of a local max. Notice that it's not the absolute maximum. Any one of the points that are on that branch are a higher value. However, in that vicinity, that point right there acts as a maximum. So, what is the x value at that point? 3 pi by 2. For that same reasoning then, this value up here is going to represent a local minimum. Where does that minimum occur? At pi by 2. Now, I just want to stop there for a second to make sure that we can see a pretty fundamental concept. That as x values change and my y values change, the reciprocal is going to have an opposite effect. And so as I start to examine and I want you to look at your sine curve, your sine curve's values are increasing. Let me just make that purple. And as they increase, your reciprocal graphs will decrease. And therefore, when you hit a maximum on your one curve, then on its reciprocal, it must be the minimum. Because as soon as we go on the other side of that maximum or minimum, as we decrease, my reciprocal must increase. So I'm going to just get rid of all of those purple arrows. But we can see then that what is a maximum on one curve is where the minimum occurs on its reciprocal. And vice versa. If I have a minimum on one, then it must be a maximum on the other. You're going to see a little confirmation as we deal with our zeros and our asymptotes. When you went through to fill in where your zeros are on your blue graph, notice your blue graph never hits the x-axis, so there are none. However, where are all your asymptotes? 0, pi, and 2 pi. We see that exact same relationship as we find the reciprocal. Okay, now we get down to intervals of increase and decrease. And what I want to examine then, for when we talk about intervals of increase, we are talking x values, and a curve is increasing when it is rising to the right. So, on my sine curve, when does my curve increase? Well, I notice that it increases from this beginning all the way to its max. And so, what are the x coordinates for that? Now, when you take a look at the brackets that I just put on, you might see why we sketched back into negative angles. The first thing that we need to look at, where does your curve, what is your curve doing at the very beginning of that interval? You'll notice that at the beginning of that interval, your curve is currently increasing. You can see it increasing there. That means that in my interval, I need to make sure that I have a square bracket to include 0. Okay, at the end of my interval, at pi by 2, notice that my red curve is neither increasing nor decreasing. It's at the top. It's actually 0 if we were to talk about an increase or decrease. And since it's not increasing at that value, I can't include it. And so I have my open bracket on my pi by 2. Now, just to be clear, you're okay if you wanted to also write x greater than or equal to 0 less than pi by 2. Remember, we never care about which notation you use. Okay, I need to get rid of that alternate notation though, because we have another interval of increase. Notice that it also increased down here at the end. So for that same reasoning, I can't include 3 pi by 2 because it's not increasing there. However, it is increasing at 2 pi because as that curve continues, it would continue to increase. So we can get rid of all of that purple. And I'm just going to get back in, the proper statement. Okay, now what we want to do is take a look at intervals of decrease. So, as I examine intervals of decrease, I am then looking for when is my curve falling to the right. I am looking for this. Well, if we notice on our sine curve, we really have one big interval of decrease in this domain. And it exists right along there. So if I just get rid of that interval, we cannot include pi by 2 because it's not decreasing. It ends at 3 pi by 2, and we cannot include that either. There you go. Now, what I'd like you to try is the same thing on your cosecant graph. So let's pause the video now. You jump in, finish it off. We'll see if we match up. Okay, we should be back. So if I'm examining an interval of increase on my cosecant graph, then I notice that I start to increase at this minimum and beyond. Okay, well, what is that interval then? Well, that interval is going to be from pi by 2, but not including it, and up to pi, but I can't include pi either because at pi, it's an asymptote. Then it continues to increase on the right side of pi and all the way up to 3 pi by 2 and not including that. Hopefully we match up. Okay, when is my curve decreasing? Well, my curve is now decreasing everywhere from 0 up to that minimum. And so, from 0 up to pi by 2. And then it continues to decrease at 3 pi by 2 and down. And I can't contain the outsides of both of those because they lie on asymptotes. Okay, I want you to take a look at a couple key things again, and just notice we have the same relationship. It just looks a little different because of the undefined values at certain points, certain x values. Notice when I'm increasing on one graph, I'm decreasing on the other. And you can see the relationship between increase and decrease as well. Okay, you've got 2 more pages in this booklet. And what I'd like you to do is to go through, complete those 2 pages, and when you're all finished, then what I'd like you to do is to come back to this video and confirm your answers. So if you'll kind of notice when you get all done, come back to this video around the 16-minute mark and we should be able to match up. Okay, good luck with your practice. Okay, and what you'll see then is just confirmation with your practice. You'll see in blue your base curve, in red your reciprocal graph. And if I was to then just slide that up so you can get a little confirmation, then those should be the properties that you see. Pause the video wherever you need to make sure you've got some time to match things up. But we should see that same relationship. A minimum on one curve becomes the maximum on the other. A max on one curve becomes the min. Asymptotes become zeros. Zeros become asymptotes. And you'll see that same relationship between intervals of increase and decrease with small adjustments for asymptotes. Okay, pause the video at any point, rewind it, whatever you need to. We're going to jump on to tangent and cotangent. Okay, I've got a big ugly mess because I've got asymptotes everywhere, and so we're trying to tell the 2 apart, but that's what your picture should look like. And now what we're going to do is we're going to slide up the table for a little confirmation, and there we go. Just remember that you have no local or absolute max or mins on your tan graph because your tan curve goes off forever and ever in both directions, and it has no change of direction. You see the same relationship between your zeros and your asymptotes, and you see the same relationship between intervals of increase and decrease with adjustments made for asymptotes. Okay, I think that does a really good job for getting the groundwork of dealing with our reciprocal graphs. It gives you a basis to be able to know them, but not have to memorize them so much, rather build on them from your background knowledge now with your primary curves. Okay, that was it for your practice for today. So hopefully everything went well, and we'll move on to the next day. Good job.